All right, greetings everyone. This is the second part of the video now for section 1.3, continuing on with our studies of average rates of change and calculating rates of change over intervals. And we looked in our first video at calculating rates of change from tables. Now we'll look at doing them from graphs and formulas. All right, so here we're given a graph of a function, and it looks like this function we're calling h. They want us to find the average rate of change on a few intervals here. So from -2 to 0, from 0 to 2, and -2 to 2. And again, recall that these things here, especially because they have brackets, these are not talking about points. So they're not talking about the point -2, 0, which first of all, you might notice is not even on the graph of the function here. So these are talking about intervals of input values. So this first one, we're finding the average rate of change from this point here where the input is -2 to this point here where the input is 0. And recall that to find our rate of change, okay, we use that function, or excuse me, that formula. And since our function here is called h, I'm going to use h's. So h of b minus h of a all over b minus a. And recall that the values for b and a come from our intervals. So our first point here, the -2, that'll be a, and then the value for 0 there, that'll be b. Okay, so our rate of change calculation then is going to look like, and sorry, I'm trying to pick a color. I guess I'll just go with not that one, this one. So we're going to have h of the value for b, which is 0, minus h of the value for a, which is -2, divided by value for b, which is 0, minus the value for a, which is -2. And then recall again, h of 0 minus h of -2, that does not mean do 0 minus -2. We need to find the output values there. So h of 0 from our function up here looks like the output value there is 0, minus h of -2 looks like the output value there is -1. All over 0 minus -2, that'll make a +2 in the denominator. On the top, 0 minus -1 will give us +1. So it looks like we get 1/2 as our average rate of change there. Okay? So we get 1/2 there. All right, let's do the third one now. So this rate of change over the interval -2 to 2. So here, again, we identify our a and b values. So a would be -2, b would be 2. Plug those into the function up above. So we have h of 2 minus h of -2, all divided by 2 minus -2. Again, for the h of 2 and h of -2, we have to identify those values from the graph of the function. So h of 2, our output there looks like is -1, minus h of -2, our output is also -1. All over the 2 minus the -2, that makes a 4. Now I have -1 minus -1 on the top, so that'll make a plus. -1 plus 1 gives us 0 over 4, which looks like we just get 0 as our rate of change there. Interesting, right? The answer for the third one here is 0. Let's also think of why that is. So notice, finding the average rate of change between those 2 points, we are starting here and going to here. And notice when we pass along the graph there, we started at a certain height, so we started an output of -1, and we end at an output of -1. And even though there's that arc in the middle, notice that the output we're starting and ending at are exactly the same. So it's almost like we didn't make any progress. So that's why the rate of change there is 0. All right. Cool. So that is finding average rates of change from graphs. Let's now look at doing it from a formula. And just like on the last one, we're just going to do the first two here. So this one here and this one here. So again, we're given an interval. This -1, 3 in brackets are not a point. That's an interval. So this will be our value for A. This would be our value for B. So rate of change here, and our function we're told is g of t. So we'll have g of 3 minus g of -1, all divided by 3 minus -1 using our average rate of change formula. G of 3 and g of -1, remember those represent the output values when the function is evaluated, each of those. So how do we find those values? Right, we need to plug in 3 and -1 into the function. So we need to do g of 3, which means up here, we need to, since we replaced the t here with 3, we need to place these with 3 as well. So we'd have 3 squared minus 3 was 9 minus 3, which is 6. And then g of -1. Can we do a similar thing? -1 squared minus -1. Right, so -1 squared, that means -1 times -1, which is +1. The minus minus here makes a plus. So we end up with 2 there. So this g of 3, that was 6. The minus the g of -1, which was 2. All divided by 3 minus -1, that makes a plus. So 6 minus 2 over 4. And if we simplify that, we'll end up with 4 over 4, which is the same as just 1. So our average rate of change for that first interval there is just 1. Okay? In this case, we don't have to worry about units because we weren't given any units for the problem. All right, so let's look at the third one then. So now we're told to find the rate of change over the interval 3, 3 plus h. And in this case, our value for A looks normal, even familiar, right? The value for A here is 3. But what do you notice about the value for B? Holy buckets, they put an h in there. How in the heck are we going to deal with that? I think we can handle it. So first of all, our rate of change formula in this case is going to be g of 3 plus h minus g of 3. So even though this is a 3 plus h for v, we can still input it the same way we did before when it was just a single number. Then we'll divide by, and we subtract these two things. So 3 plus h, because that's still our b value, minus the value for a, which is 3. And now the fun begins. So first of all, we have to find g of 3 plus h. So how are we going to do that? Well, we're just going to take this 3 plus h value here. Because it's in the place of t there, we put it in the place of t everywhere else. So up there, we would end up with 3 plus h squared minus, put in 3 plus h here. This 3 plus h squared, notice that is the same as 3 plus h times 3 plus h, which we talked about in our prereq practice. So we'd have to FOIL that out as 3 plus h times 3 plus h, and I'm not going to go through all of that right now. But if you do that, you should end up with 9 plus 6h plus h squared. And then with this minus sign here, notice that it's on the outside of our set of parentheses, so we need to actually distribute it through here. So it'll give us a minus 3 and a minus h. Notice when we do that, we end up with some like terms here. So I see the 9 and the minus 3 are like terms. The plus 6h, the minus h are like terms. So if we combine those, we'll end up with the h squared, didn't have any friends. The 6h and the minus h, that'll give us a plus 5h. And the 9 and minus 3, that gives us a plus 6. So it looks like the g of 3 plus h is h squared plus 5h plus 6. So that can be put in the place of the g of 3h plus h here. We've also already found that g of 3 was 6. So we'll put this information in now. And Please pardon me while I erase some stuff to make room. All right, so when we do that, we're going to have h squared plus 5h plus 6. So that's taking the place of the g of 3 plus h is this. Minus taking the place of g of 3, well, that was 6, recall. And then the denominator, well, notice we have 3 plus h minus 3. So this 3 and this minus 3, those will cancel out. So we'll just have h. And we can actually simplify this some more, because notice up here we have this positive 6 and a minus 6. Those will cancel. And so we're left with h squared plus 5h over h. And you may be thinking, we're done. But wait, there's more. Notice on the top that both the h squared and the 5h contain an h. So we can factor that out and have h times h plus 5, and we factor out that h over h. And now notice, because this h on the top is being multiplied by the h plus 5, we can actually cancel it with the one on the bottom. And we end up with just h plus 5 here. Woo-wee! And that is our final answer. Wasn't that fun? I think that was a lot of fun. All right, that is it for this video. I would suggest, if those last few steps kind of boggled your mind a little bit, it might be a good idea to go back in the video and maybe rewatch them, pause it, and make sure you got everything that we did there. Okay, thanks for watching.